for the other thing, temperature.
Taquitos, right? What was this? Oh, temperature. I don't think they would be able to read that.
Temperature does not rise. I don't know.
The measurement does. Technically, temperature does rise.
So true or false? Heat rises.
I think heat rises, yes, true. Heated particles rise.
False?
Heated particles rise. Therefore.
But in the atmosphere is like the heat is rise and then we like the next part of the atmosphere like it
Depends where heat's rising.
Okay.
I didn't even look at this statement.
Depends where we are.
Well, here.
Heat in this room rises.
I obviously the reason I put this statement on the board is because probably from the age that you were, well, at least here, I don't know, you guys, heat rises, is that a common phrase in China, Thailand? No? Well, obviously no one says heat rises, but I mean in your respective languages.
Heat rises.
Like we are taught from a very young age that heat rises, like 2nd grade probably. You know, they say heat rises, so that's why you want to put, if you live on a 3-story home or whatever, you can only put the heaters on the bottom floor because in the end, that heat eventually is going to go up. That's what we're taught, and so it's kind of a common acceptance here.
Well, okay, I have a question then, because if cold doesn't exist, it's just loss of heat, then we say like the cold air sinks or whatever. So does that mean that the lack of heat sinks?
What is cold? One more time, say it again.
The lack of heat?
Yeah, cold is just a lack of heat.
That's all relative.
Right. And remember we talked about relativity.
Because no matter what, you're going to have some kind of heat because it's moving.
There's all,
relativity again, what was that?
Relative to what you're talking about.
You can't use the word to define the word.
Relativity is relative.
Oh, wow.
So you can't use relative.
Yeah.
Okay. Respect of...
Respect to...
What you're looking at, what you're talking about.
Yeah, with respect to, this is broad, but I'm just going to say something. With respect to something. And that's the thing, is the words cold and hot, they're completely and totally relative. You know, is it cold outside right now?
Yes.
Yeah, but if it was December 20th, you'd be like, we're having a heat wave.
Yeah.
Because it would be hot, because relatively speaking, so everything is relative. Yeah. So we use these words and it's like, really? Is it cold? Is it hot? And, oftentimes we're comparing to, well, there's two things we're really comparing to. One of them is touch. When we touch, what number do you think we compare to?
Our body temperature.
Which is? 98. Yeah, 98.6 or 30, whatever. That's what we compare to. So this table is?
Cold.
Yeah, this table's cold. But in actuality, what do you think the table's temperature is?
I don't know, 70.
Probably 70. Is it cold in this room? No, it's pretty comfy. What are we comparing that to?
Body heat.
Not body heat.
Table.
Because think about that. If we compare to the body heat, AJ, it would be cold until it got to 98.6 degrees. You're like, oh gosh, it's 92. It's freaking freezing here. It's 6 degrees colder than my body temperature, but 92.
But we have clothes on, so it's relative to the amount of heat that we have.
But do clothes generate heat?
No, but it keeps the heat.
It keeps the heat. But still, if we were comparing to our body temperature, we would want 98.6 degrees. We would want it to be 98.6 degrees. That would be the ideal for us. And that's real hot for me. I don't know about Mick, but that's pretty warm for me, 98.6 degrees. But Mick's ideal temperature is probably different than our ideal temperature because
You grew up somewhere else.
it's not 97.
Mine is.
You do not want it to be 97 degrees. You'd
No,
be
mine
sweating
is
bullets.
97 point something.
But it's not. That's my point.
Oh, I'm saying my body heat.
Your body heat. I'm not talking about body heat. I'm talking about what the ideal room temperature, the
Yeah.
ideal temperature that you want to be living in.
75.
Yeah, it's probably like 75 for most of us. Some people like it cooler. You know, we set our ideally, I'd love to have my house at 70 all year round. It's a little pricey to keep it at 70 in the summer. But Mick probably 70 degrees would be a little too much. Every time we go outside for PE, Mick's like, it's so cold. I'm like, it's 68. But he's gotten better since he's been here, you know. But that's again this. Why?
Because he's used to a warmer climate.
Right, yeah.
This guy in Alaska, Fairbanks, a postal carrier who wears a t-shirt all year long, even in winter when the temperatures below zero, he's just out there wearing a t-shirt delivering mail.
Oh my gosh.
Now that's a little bit excessive,
Yeah.
but either way, the body can adapt. You know, the body adapts to the climate it's in.
That's so weird.
I mean, why do you think that goes back to just adaptation? I mean, is there evolution? The word evolution carries this connotation of Darwinism essentially. You guys know Darwin. Darwin, you know.
Charles Darwin, not Darwin Barney.
What?
He was a freak who plays for the Cubs.
Okay.
I say freak 'cause
You know, the stickers. Darwin. Like,
Fish?
yeah. You've never seen that on the back of a car?
I
You got.
haven't actually.
You haven't?
No.
I've seen like the Jesus.
I'm
picture.
Yes, this is Jesus.
But it had legs and it said Darwin.
Correct.
Yeah,
Yeah.
Darwin.
They have a couple of them. This is like a leg that says Darwin on it, insinuating Darwin basically said that Darwin believes in macroevolution, so that we all used to be apes. You know, great grandpa. He was an ape, and before that we were fish. Before that we were birds, and before that we were goop. You know, so great grandpa was a blob of slime, and then we changed and changed.
We weren't birds.
What's that? Before monkeys. Before.
Before
I know.
primates,
They
if
just say
they're a
that they're
fish, we
not-
crawl out of the water.
Right.
Because the fish sprouted legs.
And then the fish
Amphibians,
changed into reptiles, and the reptiles changed into birds, and the birds changed into monkeys, and the monkeys changed into humans, and
I
now.
think you skipped the bird step, but other than that, yeah.
But anyways, that's Darwin. So Darwin is associated with evolution. Now, the evolution, macroevolution, I don't believe exists. And I'm not going to push it on you or push it on anyone else, but I don't think that we came from slime. I don't believe that a pile of slime has turned into fish, which has turned into birds, which has turned into reptiles, which has turned into monkeys, which has turned into human beings. I just think that's kind of silly.
That's a lot of random stuff going completely right, you know.
You
a lot of
know,
coincidence.
it's the idea of
Yeah,
to put a point across. When I was in grade school, my science teacher, who happened to be my father, we did a lab. He gave us a box of popsicle sticks and a can of glue, and we had to take the popsicle sticks and throw them in the air, and someone was supposed to squirt glue on them. And if they landed in a perfect house, that's about the likelihood of macroevolution. I gotta take that.
Alright. Yes.
My point. Hold on. This is Andrew.
I believe what he's talking about, his point is that when we're talking about someone adapting to a temperature, we're not saying that people evolved differently in different climates.
Microevolution, not macro. Microevolution is the fact that when you cut yourself, if you cut yourself bad, then when it grows back, it's going to be slightly calloused over. You know, the fact that we have calluses on our feet is microevolution. You know, if you rub your arm for a long time, eventually it's going to be rough. You know, the fact that you shake Grant Wilkie's hand and it's rougher than Anna's hand is microevolution, because your body adapts. You know, if you were
Well, that's not. I don't know. Is that really even microevolution? I always thought of microevolution as the small mutations that happen from generation to
Correct.
generation. inherent
I'm getting
diseases.
But that leads into, you're right, it may not technically be termed, but the skin difference in color between Mick and us is microevolution. The skin difference between all of us. You know, chances are, AJ, your ancestors lived in slightly more of a northern territory, further from the equator than Mick's ancestors. You know, the sun that he got was more than, you know, yada yada. That's why Alaskan people look like this color. Well, no, like this color. Because Alaska's very far from the equator. And, you know, 3 months out of the year, they only get 5 hours of sunlight.
What about Eskimos?
Eskimos are dark.
Yeah.
This is true.
Eskimos are dark.
They migrated from Asia.
They are.
It depends on the Eskimo, I think. I don't know all that many Eskimos. How many do you?
No, it's just European versus Native American. Eskimos are Native American. Native American had darker skin.
Right. I mean, it takes a while. You know.
But that's an example of microevolution too.
But like
little stuff happens over
the
generations.
Eskimos in Russia, they're dark skinned.
You can't just say an entire an entire group of people is all dark skinned. I mean, you did, but did I? I didn't know what. Africans are not all dark skinned. If you look at someone that from relative to you, yes.
Yes.
But if you look at, I mean, even the difference between someone from Congo and someone from South Africa, generally South Africans have much lighter skin than someone from the Congo or someone from Niger, you know, because Niger and Congo are like on top of the equator, so they get sunlight all the time. But yeah, and even, well, either way, that's microevolution. That's our body adapting, being. And it goes back to relativity, and that was the small point that I wanted to make. What?
No, go ahead.
Yeah, we're going out on a tangent a little bit. So heat rises.
How the heck did we get from that?
Because we were
That was
going.
my question.
It's all about people adapting to different temperatures.
Right, adapting to different
yeah.
temperatures and skin
Right,
adapting. Yada yada.
Wow.
Adaptation doesn't mean mutation or genetic change.
I'm gonna go with sometimes.
There you go.
True or false? Yes.
Yeah.
Most of the time, sometimes.
Because with the lack of heat or whatever, there still is heat, and a lot of times that sinks. Because like you open the freezer and you see the.
Well, a lot of stuff has to be the same in order for heat to rise. I know what you're saying. You open the freezer and it looks like the cold air is sinking, right?
Yeah.
Is that really what's happening?
I don't know. I thought it was.
What causes?
Oh, the hot air is pushing it down.
Right, hot air is coming in, and the cold air basically is denser than the air outside, and so it takes the path of least resistance. So in that case, it's as if the cold is sinking, yes.
So it's choosing to go down.
It's convection, yeah.
But still.
So much stuff has to be the same for this to happen. For
Correct.
heat to rise. I mean, you have the same density, the same material.
You're wrong.
No,
You
I'm
just
not.
said that the
Yes.
density was different.
Okay, so if I put a hot block.
Let them explain. Just wait.
You just argue.
We are arguing, correct. But I'm going to hush him because I want to know what you guys think. What causes heat rising? We talked about it a week ago, but I don't know if you guys ever actually explained it.
The particles spread apart,
So?
making them less dense.
Good. Yeah, essentially. The density of hot substance. Now, we're talking about one substance in itself. And this is the point that Mr. Gottschalk was making. We're talking about one substance in itself. Hot water in itself is, relative to cold water, is less dense.
And that's the point I was making. If you're talking about heat rising, make sure you're talking about the same substance.
Correct. Right. I knew what you were saying.
Okay.
But
say put a hot block of iron, drop it in water, it's going to float just because it's hotter? No.
yeah, and that right. This is totally a sometimes thing. Is it true? Oh, yeah, it's true, but it's based upon this. And is it always true? Well, no, it's not always true. As we showed with the last thing that we talked about yesterday was the atmosphere and the fact that what's rising. What's up, what's down. Go out in space, and then somebody says, what's up? And you go, I don't know. What's rising here? We point up. Where's up? Well, up is
Toward the
up.
sky?
Towards the sky, yeah, but away from the center of the earth, It's crazy to think about, again, relativity, but shoot. It's like, I can't imagine being out in space and someone going up, and I go like this, and then like you flip around and you go, what's up? And you point down here, and you point in opposite directions,
Well, it's like when the space shuttle is orbiting Earth, it's upside down. I mean, the top of the space shuttle, what we think of as the top, is facing toward the Earth. Okay?
And then what's up? That's all relative again. Up top of the ship is towards the earth, and it's down, and that's crazy, and backwards. And so what's up? Is this up? Or is this up? Because if this is up, then you're upside down, and if this is up, then you're backwards.
Pretty sure that's the worst space shuttle I've ever drawn. But it's hard to draw upside down. But yeah, it's all relative even there.
Temperature rises.
Gravity help you out.
What?
Temperature rises.
The measurement of decimal.
Is that true? Temperature
There's more
rises?
heat.
Yeah.
I think we need to.
I don't think we can make that as a period. I think I gotta erase that period. You gotta keep going.
When there's more heat.
Temperature rises when heat is added.
Yeah. These are completely different statements.
Yeah.
Why?
Because one is
What's
the
wrong?
physical, what it does, and then one of them is what the measurement is.
What would you call that? Yeah. There's a better word.
Measures amount of
It's a
heat.
scalar. There's your hand. Temperature is a scalar.
Yeah.
Temperature measures, average kinetic energy.
Magnitude.
But temperature measures change in heat. Temperature is a scalar. Heat is a vector.
No.
What is heat? Also scalar? Or neither?
Neither.
Yeah, heat is neither.
It's a thing.
Heat is neither vector or scalar. Heat is neither a vector or scalar. What is heat?
Yeah, what is it if it's not vector scalar?
Not a vector or scalar. What is it?
Something brought upon by friction.
Something what?
Brought upon by friction.
Something brought. We talked about this yesterday. It should be in your notes. What's heat? Heat is not changing temperature. Temperature is changing
Prove
heat.
yourself here.
Transfer of.
That's what you said yesterday.
Yeah,
Yeah,
heat
heat
equals
is
changing temperature.
That's what you wrote yesterday.
You're right. Wait, am I backwards?
You are backwards.
Yes.
Heat is
I was about to
transfer.
say
Heat is changing temperature. Temperature is not changing heat.
Awesome.
Heat is changing temperature. That's backwards.
I would say
Sorry.
they're both scalars, though. I would say they're both scalars.
No way.
Yeah. Why not?
Why?
Neither of them has direction. They both have magnitude. Heat is measured in energy that's transferred. Energy is a scalar, isn't it?
Yeah, it's true.
And temperature, I mean, I don't know what you call it if you don't call it a scalar.
But if he
It's a
says that
scale.
heat rises,
Heat temperature is a
it
scale.
moves.
But
Okay,
I
I'm
mean,
talking about heat in the physics,
As
the
am
physical
I.
calorimetry sense that we're going to
yeah,
use it for.
we need to. Yeah, when we talked about work, you guys typically use work as what kind of statement? Physics or real world?
Real world.
Yeah, you work versus work. I'm at work. I'm not working. Because I'm working. I'm not working. But when you move up and down, you're working because you're fighting against gravity. I'm at work right now, work. Heat versus heat too. In the physics and the real world definition, physics, you're talking about what? Change in temp. Real world.
How hot something.
Relative, yeah, it's all relative in the real world. I mean, okay, so we know that heat is, what did you say the definition of temperature was?
No, it's a measurement of heat.
Temperature is the measure of kinetic energy of particles and substances.
Yes, temperature.
Average.
Right.
So what if the weatherman on the evening news said, "Oh, tomorrow around 3 p.m. the measure of the average kinetic energy of the air molecule is going to be about 310 Kelvin." You'd probably get fired, right? Because no one would know what the heck he was talking about.
Or some lady with free.
Yeah, things are going to boil.
A lot of people would actually.
That would be awesome.
Come up in shorts
We're all
and
gonna
flip-flops. Stand in the water.
But we would know.
Yeah.
So
We'd be the other ones going to school.
There's a few other people that would know. We gotta do the T and Q.
Yeah.
There you
So temperature is just measured with the T. Generally, you want a sub C or a sub K to not measure it. That's the variable.
What?
C, K, or F, depending on which scale you're talking about.
Okay, what is
TK is Kelvin. TC would be
Temperature. But it was all backwards. It said heat is neither a vector or scalar, and we said it's a scalar, and so.
What are we talking about now?
Talking about temperature, the variables that we use for it.
We're not going to use Fahrenheit too often, but we will have to convert it now and then. You did that for today, or you were supposed to these direct equations. Heat. Well, we talked about heat being a change in temperature, so it's got to have a delta in there, right? There's not much left. We're going to use Q.
what does Q stand for?
Heat.
Heat equals the change in heat.
No.
Heat is change in
Is that
temperature.
the
Yeah, so
thing
Q
equals
is
the
Q temperature then?
So, I'm sorry. No, this is a measure of energy.
Okay.
What does it stand for?
Heat.
Is that the thing?
Why is
equals
it
the-
change in heat?
I'm sorry. It's not. I'm sorry. My fault.
Oh my gosh.
T equals change.
Talk about
Okay, then.
energy. Temperature then will change. So we'll have a change in T as a result.
What?
No.
Yeah.
Temperature is change in T? This doesn't make sense.
Hold on.
Temperature changes. Okay?
But,
So if the temperature changes, if
Oh,
the
this
temperature
is
goes
just
from
a
20 to 30 degrees, the change in temperature is 10.
So Q is the heat.
What?
Q is heat.
Q is
Q
heat.
is heat.
T is temperature. T equals change in Q. Or Q equals change in T.
Then why is it change in
I'm
T?
asking.
Oh.
No, we don't need it.
Why Q is
What
Q
is
equals
happening?
20? Oh yeah,
Change in
What?
T equals Q. No.
that's
That's
not
what I
the
thought.
question.
Yeah, change in T equals Q, but
There's a whole equation.
T equals Q.
No. Because temperature is measured in kelvins or degrees, and heat is measured in energy,
T
in joules.
equals changing. No. T equals Q. T equals changing Q. Oh.
okay, heat is equals change in temperature.
Think of Q as
Changing
the
Q
quantity.
equals changing
Think of
heat.
Q as a quantity of heat.
That's what I'm saying.
Good. Okay.
When I was saying like
This is
what
not true though, because
Why not?
That's
this is
not-
measured in kelvins, and this is measured in joules.
Yeah. That's
Okay?
not-
So I would say this. Okay? They have a relationship,
Okay.
but they're not equal to each other.
What does that little squiggle mean?
About. No, that's not about.
No, that's not
Corresponding.
about. What?
Corresponding.
The similar or the
Oh.
Or you
related.
might even
Similar.
say,
Fish?
yeah, you know what that means?
Angular
Not angular
momentum?
acceleration.
Yeah.
Oh,
Oh,
That's also the term for direct and proportional.
I don't like it. It confuses me. Sorry.
Usually use this instead because it doesn't mix us up with angular acceleration. But that's later on when we get to that equation. And then the equation is going to be Q equals mc change in T, where m is a mass and C is a number of calories, but we'll get into that later.
Calories?
Yeah. Because calories, yes, the same calories your body uses, are a measure of energy. It's a form of energy. A calorie is the amount of energy it takes to raise 1 gram, 1 degree Celsius.
1 gram of water, 1 degree Celsius.
That's a kilocalorie.
1 gram, 1 cc.
When we eat food with a lot of calories, it's heating our body.
Yeah.
Yes.
Oh,
Yes.
that's weird.
That's why
There's
people
two-
are always warmer.
What?
No. There's two. No, they're warmer because they're insulated.
Yeah, that's what I
Yeah. There's two types of calorie. There's an uppercase and a lowercase.
The uppercase is more scientifically known as a kilocalorie. No, it's vice versa, isn't it?
No, I don't think so.
I'm
Because
pretty sure it's the
whenever
other way around.
Is it?
Yeah, but the food one, we don't capitalize even though it's
Okay.
supposed to be. But I think
Are you
food
sure?
calories are really kilocalories.
No.
The food calories is always capitalized.
really,
Is it?
I never see it. I do too, but I still don't see it.
I'll give you just a second.
Curated all the time.
I know.
I don't know. I just like looking at it, seeing how much intake I'm putting in. I don't
There's no food in this room.
Food calories capitalized. You're right.
Yeah, the food calorie is
Look at
capital C.
Flip, guys, flip to 366, please.
care. What?
366.
This goes in a different order than I was going to teach you.
What the heck?
Yep.
Internal energy stuff.
Big calories food, little calorie. The non-SI unit of heat.
Heat energy, yeah.
It's the amount of energy required to raise 1 cc of
Which is the same as a gram.
water 1 degree C. A cc is the same as a gram. A
Cubic centimeters.
cubic centimeter.
A cubic centimeter of water weighs 1 gram.
Right. So there's it's 1,000th of this box.
Okay.
You know, because this box is a meter.
Oh, 1 million.
100th. Wait, what were we talking
We
about?
got 3
Oh, you're right. A millionth of this box. A cc, a cubic centimeter. Tiny.
Roughly this.
Not even.
Yeah, not even this.
What?
Cubic centimeter, Sue. cc, cubic centimeter. You know? Cubic centimeter? Or no.
A sugar cube. Think of a sugar cube. That's about the size of a cubic.
cm cubed. Yes. cc is cubic centimeter. Yeah. Cubic centimeter. So it's the amount of energy required to raise 1 cubic centimeter of water 1 degree C. That's what a calorie is.
In the food world, we use a kilocalorie, which is the same as capital C calorie, and that's 1 kilogram of water, 1 degree Celsius.
Right, so this is also
So
known
that
as
is
kilocalorie.
1,000 cc's. It doesn't have 1,000 times the volume,
Kilocalories.
though. It's
no,
1,000
so
times the.
No.
Yeah,
Kcal is not the
all
same as food calorie.
Dietary calories, food calorie, kilocalorie
See?
is just a unit of heat, non-SI unit of heat.
Uh-oh.
Oh, you're right. They're equal, AJ.
They're equal, but
Look, yeah. So, okay.
We just use them to
The
know
sugar
different things
cube.
because in the body, who cares about raising the water in our body 1 degree Celsius? We use it for a different meaning, but it's actually got an equal measurement, equal magnitude
To kcal, not to cal.
to kcal. Yeah.
So, the calorie in the food is exactly 1,000 times the calorie of
Mr. E.
science. Does that make sense? The calorie in the food is exactly 1,000 times the
1,000
calorie.
times the energy.
1,000 times the calorie of science.
The
What-
calorie we're talking about is not the C in the equation, is it?
No, it's not.
No. Oh, the C over here.
Is that C? No.
No, because we have energy over here. The
Yeah.
C is going to be specific heat. Actually, it should be
Yeah,
CP.
Correct.
Specific heat capacity. That's what it will be.
It's just confusing. You talk about that equation and then talk about this calories.
There's
Yeah,
too
we
many
saw the
C's.
C in, when the C doesn't always represent something, we're just jumping back and forth. We're trying to introduce everything at once for 3 sections, so we apologize for not being in order, really. Alright, so getting back to the stuff we're working on now. Okay, now I know what a calorie is, so that's good. Remember that. The first section dealt with temperature conversions. We don't need to do anything with that, right? You know how to convert temperatures. Converting Celsius to Fahrenheit and vice versa. You guys all know how to do that? Is that a yes or a no?
What?
Do you know how to convert temperatures between Celsius and Fahrenheit?
Yes.
Yeah, we just did that now.
Celsius.
Get a
is
Celsius
about
temperature.
1.8 degrees. Fahrenheit.
Well, yeah, which is-
1.8 degrees Celsius.
Plus
Yeah, it's 9/5.
9.
And then,
Depends which way you're going.
yeah,
Oops.
TF equals
Wait.
9/5C
Minus
plus 32
32.
plus 32.
Is that in parentheses?
One of them is a quantity.
Which one is quantity? I believe it's this one.
That one, TC is quantity.
Yeah. So it's F plus 32, right?
TF plus, no, minus 32.
F
Yeah,
minus
yeah.
32.
Okay.
5/9 times the quantity Fahrenheit temperature. So, for example, 100 degrees Fahrenheit, 100 minus 32 is 68, and then multiply that by 5/9, which is roughly half.
Now, if I want to derive that for Fahrenheit, just so you see how the quantity comes out, you usually know how this works anyway. We get rid of our fraction. 9/5 TC equals TF minus 32. Put the 32 over here. So TF equals 9/5 TC plus 32, no quantity. You do the multiplication first in that case. So that's the part that screws everyone up, okay? Which one's a quantity, which one isn't? Make sure you remember which one is.
Put those, this is on the page before.
There's that so
This one's
nice.
on the page before.
This
Make
one they
sure you
don't
have
define.
this one down also.
Put them both in your notes. They only define the one, because you really only need the one to find the other, but it's easier if you have one of them isolated.
Technically, put that in there too, right? Temperature in kelvins plus 270.15 will also give you Celsius.
Remember we said that yesterday? Is that it's not exactly 273,
Yeah.
it's 273.15.
And you're gonna have to write like this. If you prefer to have this as a separate one, so you have 2 things that equal TC, that's fine too. So, page 362. We've talked about temperature scales. We talked about it last section, Fahrenheit, Celsius, and Kelvin. Remember the origins of those scales? What's the origin of the Fahrenheit scale? What is it based on? What was the dude testing?
What?
Remember origins of Fahrenheit and Celsius?
Yeah.
What is the Fahrenheit scale based on?
It was on the point like that.
You know-
freezing point of
Fresh.
fresh water.
No.
No.
Salt.
Salt
Or-
water.
yeah, 0 degrees
Fahrenheit is
Fahrenheit,
salt
salt
water.
water, yeah.
Celsius is on fresh
Fresh
water.
water.
Celsius is fresh, right. And Kelvin's is,
On absolute zero.
right.
Right. It's based, so Kelvin is based upon.
No movement.
Right.
Kelvin's
Kelvin
is
is
based on-
based
yeah.
upon particle movement. Particle movement.
And you'll see that in that blue chart. What is Kelvin's used for? Physical chemistry, gas laws, astrophysics, thermodynamics, anything physics, right? Celsius, meteorology, medicine. Fahrenheit,
And the world.
yeah, the rest of the world.
U.S.
Outside US.
Outside U.S.
It's true.
It is true.
Says U.S. and
Yeah.
Yeah, does
US
Canada
and
use
Britain.
Fahrenheit?
Nope, Celsius.
What about Britain?
I think they still. No, I think they're Celsius too.
Britain, I think, uses Celsius.
Everyone uses Celsius.
Even Canada?
Yeah,
We're just
yeah, Canada.
They make fun of us for using Fahrenheit.
And they should. Fahrenheit is arcane. It's stupid.
No.
I wish we didn't use it. Yeah, you think it's stupid to use anything else because ingrained in our minds is Fahrenheit. It's
I'm
so
going
hard
to
for us
teach my
transfer.
child Celsius.
I kind of learned.
That's
My
You
what
grandpa
don't
taught me.
have any sense of that.
My grandpa.
Yes,
teaches
I will.
us
Next year, I'm gonna
teach
learn-
me
I'm gonna know
everything in school
Celsius.
when I was in, like,
Body
fifth grade.
temperature?
What?
Body
I don't have
temperature?
it yet, but next year when everyone uses Celsius, I'll know.
Next year.
Yeah, one
After
day
China
you'll
takes
become
over.
body
Oh,
temperature,
you mean okay?
it's
I thought you meant after
30
China took over the United States. I forgot you were going to China.
Oh, yeah.
You know?
It's
Sue is-
36.7.
Sue is a skeptic.
No, you gotta ingrain it. I mean, I'm gonna teach Henry about Celsius. Better
Yeah.
believe it.
What's
I gave
temperature?
Henry last night the space quiz. I'm giving my earth science class today. I mean, orally, of course. Henry got an 84%.
Oh my god.
See how many of my students he beats.
And then at the end go, Henry beat most of you guys.
Yeah.
Just test.
Well, he's had a little more study time than them. I mean, honestly, when he's like space
Study
for over
time?
years, so
Well, yeah, but still.
still kind of
He's
cool.
So
like
does he know who the first astronaut in space was?
The first American, yeah.
He doesn't know that. He doesn't know about
He knows about Yuri Gagarin if I help him
Yuri
out. too.
Gagarin.
You
Yeah.
know, a lot of times I have to give him the first name, then he'll fill in the last.
Say it.
Yeah, I'd love to hear him say it too.
Me too.
Yuri Gagarin.
Yuri Gagarin.
You're saying it wrong. It's not
Oh.
Gagarin, it's a Gagarin.
Figured out.
All right. Anyway.
Wait, where's the US thing?
Yuri Gagarin.
Hey Jay, where's the US thing?
All right. So a no-brainer,
Oh,
easy
okay.
assignment for Friday should be to do page 363, right?
Actually, just do it now.
What?
We'll give you a little break here from lecture.
Okay, that's cool.
What?
Do it now. While you do
Take
that,
about
I'll pass
10
out-
minutes here.
While you do that, I'll pass out your tests.
Then we're gonna start talking about heat.